Hi, I'm Joel. So we'll get started here in just a second. I'm going to call up my lovely Vanna White-like assistant here, Vaughn, and he's going to help me out here. So we don't have a lot of time left. We've got about 25 minutes. So what our goal is to do here is to walk you through a couple of demos and show you the FlashArray in action. So there's a couple of things that make this challenging. It kind of manages itself. And showing you things happening quickly isn't terribly exciting. Like, wow, okay, so here's some things we provision really fast. So what we're going to try and do is a couple of things. We want to show you sort of the basics of our device. We want to walk through some specifics that we think are compelling to you. And then we'll show you some things both in vCenter and in Hyper-V with Microsoft System Center so that you guys can see a little bit of how we interact with both of those hypervisors and some of the benefits you can expect from the FlashArray. So fundamentally, as a VI admin who's managing virtualization on a FlashArray, the way you deal with storage changes because you stop caring a lot of things. You stop caring about RAID configurations and tuning your deduplication and spares and how you tier and all those sorts of things that a lot of virtualization thought has gone into around storage to essentially patch the problem of storage performance have been pulled out. Another thing that's key is that today, particularly in vCenter, we have 100% management through a plugin there. And so we'll show you that as well. But this is a symmetric active-active array. You know, we have no multipathing. We don't have to think about all these other storage things. And so what I'm going to show you fundamentally is the simplicity of managing it both through our interface, through vCenter, and some of the aspects of running in a Hyper-V type environment as well.
About multipathing, you have some tuning about how many IOPS you have to bring on one path and then switch to another.
So we're fully active, so you point at our array, and that's it. So there's no tuning, there's no choosing which path, there's no direction of IOPS. The path you point at us through, we will handle all the IOPS on.
1 second.
There's no passing between controllers or anything once it gets to the array. You don't need. What I'm saying is you don't need to use a Lua or anything like that.
So we advertise via Lua, but both are preferred paths. So you basically,
exactly.
pass I/O down both controllers. There's an InfiniBand connection between the controllers, and that's how they communicate and pass I/O between them.
There you go. Thanks, Vaughn.
Sorry about that.
Yeah, no worries. So I'm going to show you two arrays here, and Vaughn is going to drive while we're doing this. It's his laptop, so we'll let him do that.
Apologize about the resolution and the wonderful whatever it is.
Yeah, and their wonderful array. So this is the first array. This is an active array that's currently in use. Our SE team globally is using it to do a variety of different types of things. So we're really looking into it. We're not going to play with this array because we don't want to hurt what they're doing. But you can see we're running some significant amount of load on here. The IOPS that are coming in here are around 212,000 IOPS, right? So that's a lot of IOPS. Latency is sub 0.2 millisecond. And you can see some things of what's going on here. The array is roughly 21% full, and we've got 4.2 to 1 data reduction. So that's globally in the overall data reduction. Thanks.
Where would you like to go?
Oh, no. So you can check in our interface, latency, IOPS, and bandwidth. Can you click down here on the 24 hours and pull up an hour or something like that down there? So you have the ability to look at these statistics throughout everything. So that's very, very useful. You also have over here in the dashboard an array status. Everything's green. That means it's running, and everything's up and operational. So you can very, very quickly look and see the status of everything going forward. Can you click on storage, please? So here you can see all the hosts and volumes associated with this, what's operating here, and again you get the same sort of information about data reduction and the space consumption. Why don't we go into analysis really quickly? And can you look at what's a good active volume? Do you have a good one that we're using that's pretty active? Chad's LUNs. So you could, regardless, we can,
I don't know.
I don't know which volumes are most active here, but you can choose by individual volume, do all that type of tracking and analysis per volume. But what I think is interesting here, go to system here, Vaughn, really quickly. Here's a cartoony picture of what's going on with the array and all the different drives and components therein. If you could click on connections really quickly, that's useful. So here we have ports on the array, devices that are connected into them, and how their paths look. There's a lot of information on this screen, but it's very, very useful if you're trying to figure out how things are plugged in from host to array and what paths they're using. Configuration is great. So here's how you configure the array. One of the things we're very proud of is the setup documentation for our array fits on a little fan fold card about this big. And when you fold it in half, it's the size of a business card. There isn't a whole lot to configure on a flash array. It just sort of works. So you got to enter in its name, and it'll tell you information about it. You have to set up its IP addresses and its iSCSI ports, and got to give it DNS and all those other things. Support. You connect it for phoning home so it can call back to us, and we can provide you some proactive support. Alerts, who it emails when something goes wrong. SNMP, you go to system. Network time protocol. Directory, so for Active Directory. Banner, people who log in through the GUI, what they can see. UI, idle timeout, syslog server. So this is essentially it. When you have that in, this array is fully armed and operational.
Yeah, let me jump in. So what I would add is there's a point of emphasis here. Sometimes we show this interface and someone says, well, I have a storage background and I'm not seeing the tunables and parameters that I'm used to. This is by design. We are providing you a symmetric active-active array and a pool of flash behind it. The data protection is logical, right? The provisioning mechanisms are just based around what capacity do you need and what host does it need to connect to, right? Everything else is managed much differently at a logical layer, not at a physical layer like you would with a disk-based system.
Can you go down to plugins really quickly? And so then you can talk about vSphere. You can actually push our plugin out to vCenter so that it's installed. Can you look at?
Do you have the IP?
I don't have that IP address. You do. Yeah, you got to kill off the HTTPS header. Don't look.
Expired cert.
So we will push install the plugin from a controller into vCenter.
Yeah, so I was going to do that on the other controller, but
It's okay.
yeah. So you can push install the plugin. It takes a little while. We'll just wait for a second here. You want to look at, while we're waiting for that, do you want to look at the other controller, or you want to just wait for that to complete?
I think we're done.
Yeah, there we go. Okay, so now vCenter's got the plugin in it, and in fact, it actually says it's all there, right? So we can cancel out of here, Vaughn.
Yep.
And let's go to the other array, which is our tier 1.
This one?
Yeah, that one. So this, thanks. So here's another array running a different set of workloads. You can see its data reduction is much lower. Also, its latency is extremely low at this point, and its IOPS are extremely low. It's not running much of anything right now. And we're going to do some provisioning on this particular array as we go forward. So, oh, there's something that's blipping up. Okay. Somebody's doing something on the array.
The latency that's shown there in that graph, is that just the latency from when the array itself receives the information and then needs to get to disk? Or is that latency between the host all the way down?
The latency is measured between the host's transmission and our acknowledgement and vice versa. Okay. Obviously, there are layers in the I/O stack within virtualization that can negatively impact your latency. And not to take away any of the surprise Joel's going to share with you, he was going to talk about some of that.
Surprise. Yeah.
So do you have any insight above that layer? Can you see anything about what vCenter knows, a VM or anything, or just at the volume level?
So you wouldn't be doing that necessarily in our interface, right? We're really tracking the storage. That's a great segue maybe for moving over into the vCenter.
Yeah, what I would say is when you need to understand how an application or a virtualized infrastructure software package is working with us, we tend to then rely on their management tools and their availabilities to plug our technologies into those tools. So for example, if you're wanting to understand holistically at a VM granular level of detail and reporting, and across all of the infrastructure components, compute, networking, etc., you want to look at something like vCops or a third-party management platform. Our focus is on delivering the latency in the storage layer.
And really what you should be concerned about as a VI admin looking at our device is, is there capacity there? What's that latency, right? And that's all we really want you to worry about for us.
Where do you want me to go from here? You want the web client or back to Prezo?
Let's go into the web client really quickly. So here we are in vCenter. And why don't we start by just clicking on the Pure Storage icon, because it's such a lovely
Trying to make the view smaller.
orange color.
I have another real quick question from Twitter. When you're setting that up, that quick setup you just showed us, do you have any API that we can leverage to set that up with? I mean, I know it's really easy, but that's the question.
So we support, we have full support for REST APIs. So you can leverage the REST APIs for provisioning storage. I don't know if the REST APIs go into supporting commands around configuration and setup, but I can chase that down for you.
Okay, cool. Thank you.
Yeah, we can look into that. At some fundamental level, it has to be configured enough to talk to the world before you do configuration with it, right?
Right.
That's just the reality.
Not
And
necessarily.
at that point, there's like one thing
Use
left,
IPv6 service discovery and register a service, and it can be seen by a management agent that then triggers a function that does that initial config. It's such a trivial initial config that, whether there's a lot of value in that, it's another matter.
You have 15 minutes.
Yes, sir. Yeah, why don't you click on, so here we have one of our arrays, the one we were just looking at, and here's our lovely plugin. And you'll notice it looks startlingly familiar because it was just what we were looking at before, right? Same tabs along the top here, storage analysis system and messages, etc. Do you want to go back to the deck really quickly? Why don't we go home just really quickly?
Deck or home?
Why don't we go home in the vCenter client? And just click on storage really quickly. And click the Pure Storage part there, right? So we'll just show them that as well, right? So we have information on each one of the data stores as well, which is going to give you. Well, your screen resized kind of badly, didn't it?
Hold on. Yeah.
What are you doing?
Trying to unpin this and make it narrower. There we go.
There we go. Sorry about the resizing problem, but right. So if you could scroll down just a little bit, Vaughn, right? So we can. Can you click on where it says 0 milliseconds latency on the zeros? There.
A note on the screen resolution. We asked them to have this be the resolution because it fits best in the video.
Oh no. And we totally understand that. We just apologize to people who are watching because that may not be as fun for them just to see it. Right, but you got a lot of information there. So why don't we now go over to the presentation really quickly and just take a look. Thanks. Oh. All right, Vaughn, what are you doing?
You move.
Okay. So we're fundamentally sort of changing the basic ideas of what you do as a VI admin in storage, right? And one of the key problems we've had before is this problem of misaligning guest operating systems. The blocks of the guest operating system, the VMFS blocks, and the arrays, chunks, or stripes are misaligned, and so you end up with inefficiencies in how much you store, how much you have to call when you're reading or writing that. You get a lot of challenges. Now, with the Pure Array, we really have these little 512 byte blocks. One of the things, and Neil talked about it a little bit, one of the things that happens when you have an abundance performance is you can do things like 512 byte blocks, which gives you that granularity so you don't worry anymore about alignment. It's one of the ways that we can capture the performance of Flash and performance of the system to make things simpler rather than, super duper duper fast. It is very, very fast, but we can take some of that speed, some of that capability, some of that CPU, and build 512 byte blocks as we write them, so that no matter how you're aligned, you end up being aligned at our 512 size blocks on the device itself. So we don't really worry anymore about misalignment. And it goes back again to what Vaughn said about control over what's going on in that VM, right? We have people on our organizations who are deleting VMs, moving VMs, playing around inside VMs, and there will be misalignment. It's just what happens, right? And you could do that. You could deal with misalignment a couple of ways. You could spend a lot of time with regular processes trying to go and align all of those devices, all of those VMs, or you could build a system that doesn't break when you misalign, right? So that's kind of what we tried to do here. And that's what those 512-byte blocks give for us.
A quick note on that, if you look at many of our Flash competitors, they're all natively tuned to the 4K block size, and this issue really bites them in performance in a lot of areas. So we'll go head-to-head on performance with devices that sometimes advertise that they're million IOPS devices and beat them on performance for this reason.
Yeah, real quick, and it wasn't in the content here, and we're running out of time, but to add to Matt's point, which is while we are very granular on the block size on disk, we are adaptive in the I/O size, and we should have included this in the session, meaning we will adapt to whatever the I/O that the host wants to send. Now, storage controllers can't control what the block size of an application is or what the frame size in Fiber Channel is, right? We receive the frames, we disassemble, we look at a block. With our adaptability based on the 512 geometry boundaries, we adapt to whatever that size of I/O is and acknowledge back to the host. What you find in a lot of storage architectures that have implemented 4K block boundaries on the SSD level, that's the same level of boundary within their NVRAM or their battery-backed DRAM level, which is where they're acknowledging writes. And what they're doing is as the write is coming in, if it's not 4K, they actually have to break it down, provide validation of the block, checksumming of the block, and then look at all the 4K blocks together and then acknowledge back to the host, which actually will drop their performance. And so sometimes when you get into the flash space and you think it's all flash and it's all fast, the devil's in the details in terms of how can it handle I/O block sizes.
Well, and I think that we hear a lot in here, these sort of inflated IOPS numbers from vendors in this space. And what I would say is, first of all, those tend to be very, just like from any vendor, right? It tends to be a specific block size or a specific workload that gives you that. But then additionally, what I would say is that it's the adaptability that makes the most difference in a virtualized environment, right? Because things change and because you don't have the control over it that you'd like, you need to be able to do that. So let's talk about this a little bit here, because this is kind of interesting. Thick, thin, thick eager zero. What's the best type of VM to have, and why do you have it, right?
Yes. Oh, wait.
Yeah.
Yes, yes.
It depends.
It depends, yeah. Yeah, those are the two stock answers. It depends, and it's on the web, right? Those are the two. Go to the web to look. But there's a difference in the way that the virtualized layer looks at thick and thin when it writes to us, right? One thing you should know about thick and thin and eager zero on our device is it's the same size when you put it on our flash. Because anything that is just zeros, we don't write. Anything that is empty, we don't write. So it all goes thin on us. So the amount of storage you consume becomes a management construct at the virtualization layer, the VMFS layer. But for us, they all look the same. So then it becomes a question of performance. How does this work? And when you go about doing operations in a thick eager zero VM, it's very, very easy for the array and the virtualization layer to talk. The virtualization layer says, here's this giant VM. And we say, thank you, right? But when it's a thin VM, the virtualization layer actually has to look in to the data store and think about how much it's allocated versus how much it's used and do some calculations there and try and send different sets of information around. And that involves overhead, not at our layer, but at the virtualization layer. And that's an important thing to note. The reality here is that you can really simplify how you go about doing management as you provision VMs between thick and thin, because you can just eager zero thick them and we will handle it for you. So this is again another concept associated with Flash and the pure flash array, which is we can take some of that complexity out of the VI admin's realm and just let you write it as thick eager 0. And then we'll dedupe and compress it and make it all work on the back end without you having to worry about it as much. So you don't have to worry about over-provisioning those data stores. SDRS migration is kind of a thing of the past. The capacity is the same for either on our array. So what we want you to manage is actual capacity, not logical limits, and worry about those sorts of things. So let's do our thin or thick demo.
Is there a, I'm probably hopelessly old school, but is there a command line interface for the Pure that would show the writes and reads to each disk?
Absolutely.
Yeah. So Barks, you're going to show us some command line interface on the array when we get into the Hyper-V components as well, too.
Yep.
We've got about 7 minutes remaining.
So what we're going to show you real quick is there was an element that came up in the conversation earlier which said, are there elements in the virtualization stack that actually can impact your performance? And the answer is yes. Part of the construct between thin provisioning, lazy thick, and eager 0 thick is that when you're implementing eager 0 thick, your space is allocated and your virtual disk files are formatted. It behaves without the hypervisor does not interrupt any of the I/O flow from application down to the storage stack. It is optimal design, particularly when you're investing into a flash technology, be it a hybrid or any of these other technologies you're looking at, or in an all-flash array, that you eliminate these other unnecessary bottlenecks. By contrast, if you look at thin provisioning, what you are allocating space from the data store on demand, you're also having and suspending I/O to do that, as well as having to format that virtual disk while you suspend the I/O and then complete. We will launch real quick 2 very small virtual machines. Each one's on its own data store, so we can show you the details to it. And while we launch these 2, we will
thank you, sir.
Show you their performance. They're both running the same benchmark, the same load. They came from the exact same clone. And we will show you the I/O load that's on each of their data stores. One is on data store 6, one is on data store 5, which I don't see here, so let's bring it up in our nice GUI.
There it is.
Okay.
There we go.
And we will show you the nice,
Now let's unpin that thing.
pretty throughput here as these VMs start to boot and run. Is this working for you guys?
Yeah.
We're really bad on this resolution, guys. So what we're seeing here is bandwidth running on this virtual machine at about 80 megabytes a second, okay? Latency at 1 millisecond. This is a thin provision VM. Its counterpart, that is thick provision, runs on data store 6, running the same workload. Can we close it? Come on. You'll see here is in the hundreds of megabytes per second range. I don't know why that's
It's just ugly.
performing poor here. Yeah, that's actually a three-figure number here. Sorry, we're getting really wonky results here. But basically, what we're trying to demonstrate between the two is, and again, I can't make the resolution smaller on this to show you greater detail. That what occurs up in the stack can impact performance. And that's in addition to elements such as number of virtual SCSI adapters, etc. For sake of time, I'm going to dump out of this and put you back in control.
All right. So thin is not necessarily thin, right? We have a change here. Thin provisioning is not about data reduction on the flash array. Thin provisioning is a management construct. It's an on-demand provisioning model. It is a way that you serve storage rather than a way that you actually store the data. Thin will eventually become thick too, right? We have a bunch of challenges with the way that we unmap data, for example, or things that get stored in those thin devices. And so that's really important. VMware supports at data store level the T10 UNMAP capabilities, right? Hyper-V will do it sort of end-to-end. We're going to show you that end-to-end here with Rob in just a minute. But it's important to note that again, that thin provisioning isn't necessarily going to give you any benefit here. What it is going to do is give you overhead at the virtualization layer on the flash array, which can slow performance down. Do you want to run the T10 demo? We're really kind of cramped for time here. Rob, you ready to come on up and do that? Let's come up and do that, and just quickly run. Where are we? Yeah. So that's next. Here.
Close your thing.
Yes, probably. Just sit it on top right here. Just lean it right against there and pretend it's not even there. Just do this. Hey!
All right.
And it's all Microsoft from here on out, people.
So hopefully everybody can see that, and I'm not dual displayed.
Let's get you a mic here, Rob, if you're going to talk. Sorry.
We almost certainly can't see that in the video stream because that's way higher than resolution that can be streamed.
I'm actually running a 1024 by 768.
Okay.
You'll have to call out the interesting elements.
I will hold your...
Yeah. So one of the previous questions was a CLI. So we have a command that you can run called pure monitor. So pure monitor in this case, these are all the different volumes that I have on the array. It'll actually give you I/O and everything else, read, writes, and everything else. I don't have much activity going on in this array right now, but that is a way to do this. So everything you can see in the GUI, you can actually manage directly from the CLI as well.
Is this just a raw SSH right into the controller, or is this an external call through like
SSH.
Python or CSS?
This is SSH.
So
I'm sorry. What was that?
He was asking how you were connected. I said in your connection is SSH.
That's through PuTTY. So yeah, now I can see. So quickly to go over to the array, if you look at, you saw the GUI, so just to kind of show you, so this is actually an array that I use that's a multi-workload array. So I'm actually running Exchange, SharePoint, SMB services, everything pretty much that a Windows business would be running, right? In this case, the thing to focus on here is this infrastructure VM volume that I have. So this volume, you can see I've got snapshots associated to it. You can see that my utilization of this is actually 611 megs. The most interesting thing to point out here is I was doing some testing today to prepare for this demo. I've done numerous copies and everything else, and literally by just sitting here and waiting the last 45 minutes to an hour, I've actually already reduced my footprint of usage on this as well. So we're constantly doing things in the background to make the best use of the storage that you do have.
And that's what Neil was talking about, right? He's like, if the processor is idle, we should run a better compression algorithm. We should run a better, right? We should be doing something with that excess processor to make the array run better.
So the point here is to show you that this is connected to a host, and that host that I am going to go over to now, this is a remote desktop. This is a Windows 8 virtual machine running in the new VHDX format. And this is being hosted by a Windows 2012 R2 box, just running vanilla Hyper-V. So not necessarily System Center full-blown, but just vanilla Hyper-V. Oh, okay. So in this one, I essentially have 10 ISOs that I've created. These ISOs are real ISOs. I renamed them all. They're actually ISOs of Microsoft products. So I renamed them all. They're not zeroed or anything else. So the point here is showing that from a VHDX file through Windows 2012 that's being hosted on our array, we do SCSI UNMAPs, and we can reclaim that space directly from that virtual machine itself. So as I delete these files, if I did, so I just nuke those files from that actual VM itself. We take a little bit of time in order to go back and reclaim that space.
Do you have to empty your recycle bin?
No, it was too big for the bin.
Yeah, too big, so it empties automatically. So if I, had done this earlier, you would have noticed. So you can see here, just like I showed in the GUI. Let me do one more. Kind of bring it up a little bit.
Sure.
You can see from the GUI, we actually claimed that there was 611 megs being utilized by that particular volume. We're right now doing the unmaps. If I were to, there are ways of going in and actually looking at what's going on in terms of looking at the details in the array. So these are, all of these right here, these are all the unmap issues that I just performed to clean up that array and regain that space. And as I do check on space, this does take, it does take a couple of minutes because we're not just consuming CPU right now, because there is other activities going on in the array. But we will reclaim all of that space all the way down through the VHDX, all the way down to the actual physical array itself. Yeah. So that's essentially, what this quick demo was to prove.
Yeah. What I think is critical while we're waiting for the accounting process to kick in on the space return is that thin provisioning really does not reduce data, but it is a technology that's now starting to enable elements like T10. And obviously the hypervisors are at different levels in terms of their enablement, right? Windows 8, Windows 2012 natively support T10. ext4 file systems support automatic unmapping. ext3 supports manual. But when we can get beyond just unmap at the hypervisor and worrying about when virtual machines have been deleted, but actually start to address where the data actually is deleted and sits resident and actually expands our storage footprint, which is inside of physical hosts and virtual hosts, and we can unmap through the whole stack. Now thin provisioning actually will start to enable data reduction technologies.
Yeah, and when you think about where all that storage is, right, it is in some cases the deletion of VMs, but I mean there's huge amounts in like page files and all over scattered throughout. ISOs, people installing or deinstalling or copying over big files like that. And that space reclamation is really, really key.
Does the thin provisioning benefits you have, do they apply to a raw disk mapped from the array in through to the virtual machine?
Yeah, understand that regardless of how you provision it higher in the stack, we will only store your actual data. And in other words, everything on us is natively thin provisioned.
And if I format the Windows volume inside the VM, i.e. write zeros across it, still not costing me storage?
We drop all the zeros on our back end. So this is why Joel was sharing with you that eager thick provisioning will provide you the best performance, but also simplify your management between the layers, between your virtual machines, your shared storage pools, and you can really focus on capacity and performance at the flash array level.
Yeah, there's of those 5 ways that we talked about for data reduction, 2 of them are really germane here. And they're the pattern recognition and zero recognition, right? And it's just well understood that we write zeros in a lot of cases just to claim space, right? Just to initialize that space. And anytime that happens, we'll actually recognize as the I/O comes in, there is a series of zeros here, and we'll just put that in metadata that take it as written that we put all the zeros down. Right?
Yep. And meanwhile, Barks is up there with the spotlight on him while he's running live without a net.
All right, so in our waiting moment,
Yeah,
I know
so-
we're over time.
Yeah, what-
questions about this or other stuff?
Do you implement also ODX on Microsoft, like VAAI on VMware?
ODX support is in our roadmap,
Okay.
so we will support that long term.
And
The ODX APIs are very similar to VAAI. It's active.
And
Okay.
how does it work with VDX, VHDX disk compared prelocated with dynamic? Because VHDX is not is a structured format, is a little more complex. Is not just filled with 0, but if you use dynamic or prelocated, which kind of difference do you see on storage side?
Yeah, so again, as Vaughn pointed out, however you provision, we will be doing those types of data reduction on our side. And so, although it is a little more complex than zero writing, if there's any pattern whatsoever, we'll deduplicate that, right? We'll compress that, absolutely, and we'll recognize the pattern, store the pattern, and then write it across. I think. So, we're kind of out of time, and there's just a million things to talk about, and so we'll kind of cut it short. I know that you guys have. We're glad we got you on the first day because I can't imagine how blown out you'll be on day 3. But this is kind of where we're going here. We've got huge sets of feature sets around resiliency, around our manageability and our simplicity, the ability to run multiple protocols and make it simple for you. We've got security. One of the things we didn't talk about is that we also encrypt absolutely all the data at rest. with no management from it. Just when we write it, it's encrypted. When you pull it off, we decrypt it. That's very, very protective, and it helps build your security and your compliance posture, and lots of interoperability and integration that we have today and that's coming in the near term. So we've got a wealth of information here. Most of this information you can find on our website, as you might expect. For those of you here in the room, hopefully we'll have some time after this. We can talk about those items that you have more specifically. Vaughn, if you come up for a second, and maybe Matt as well, just for a second. I think that we're essentially done here, Stephen. But thank you guys for being up here with us, and thanks for your patience for seeing us here today. I think, Stephen, with that, we're essentially wrapped.
Okay, thank you.